Awesome, thank you. And thanks everyone for joining our session today. Today we're going to be talking about, how do we activate business data with Neo4j. We are a tax technology and transformation practice at EY. And so we work with a lot of different clients in the financial services space. And so we'll talk a little bit about some of the approaches that we use to move from data warehouse into getting some additional value out of the data, specifically around the relationships that we can get from Neo4j. So we'll kind of jump in. We'll lay out the agenda. Today we'll just introduce the team a little bit. We'll talk a little bit about why relationships are really important in financial data, specifically around tax as well, and a little bit about why it's especially important within the financial services world. Next, we'll talk a little bit about the solution we built, how we built it. The focus here is really, how do we move from this data warehouse? We built tax data warehouses for clients. We have Snowflake, and we have a lot of different processes to make sure the data in there is really high quality, and then we get a lot of value out of that tax data warehouse. And so, how do we bring Neo4j? How do we bring Graph into the mix? Right? How do we convince clients that this is a really valuable thing to add, and what is that value, and how do we show it? And so we'll talk a little bit about how we go on that journey, and then finally we'll talk about some of the key learnings that we had, right? And so starting from, like I said, having a good high quality data warehouse, and then having the conversations with different stakeholders, not only our clients themselves, but also internal stakeholders, really trying to show the value of the graph and how we approach that. And maybe some of you guys might deal with that as well, right? You have different stakeholders, and graph sometimes for business people is not really intuitive for them to grasp. And so it's really important to be able to kind of walk them through that value and show it. And so we'll kind of talk about some of the things that we learned on that journey. So jumping right in, the team here, Joe Schoon is on the line. He's our fearless leader. He actually leads the entire tax technology transformation practice, or TTT, within financial services at EY. And then you have myself, Han, who's over here right next to me, and Jack, and I have a few people on the data and AI team specifically within TTT. All right, so let's jump in. Why do relationships matter for business, right? And so, our clients, one of the interesting things about being in tax is that, we actually utilize all kinds of data across the entire organization, right? So within tax, and specifically within financial services, we need data about the actual organization themselves, like financial data. We need accounting data. Financial services made up of funds with investors, and so we need investor data coming from maybe a CRM system like Salesforce, or sometimes Excel files, right? We need information about the legal entities, the jurisdictions. Basically, tax is a consumer of data from all across organization, and so how do we bring all that information together and get value out of it, and then be able to utilize it for the different things that we need to, specifically for tax. Now, these are, kind of tax compliance processes, such as filing returns with different taxing jurisdictions, sending estimates out to the investors, right? There's a lot of different tax processes that happen, and we really need to bring all this data together across our entire client's organization. And so, one of the common challenges, really across many organizations is, each piece of the organization has their own technology. They might have their own databases. They might have their own platforms that they're using. And so they store that information. Maybe some of the more mature organizations might store all the financial information into one data warehouse. But oftentimes we see some clients really just storing everything in a really disparate way, right? Every domain, every piece of the organization has data that is needed for tax, and they're basically only responsible for storing it for their own purposes. And so it's a challenge to bring that information together.
Yeah, and to add to that, as Mike is highlighting the problem, where we have every single different business unit having their own databases, their own applications, they have their own business problems. The concept though is the same. What we call legal entity is the same object across multiple different systems, right? And then one thing that I want to also highlight is that, as Mike is pointing out, that okay, all the data is across multiple silos and everything's in a different relational table. One of the things that's missing between these things is as he pointed out, the relationships, right? And this is where this is important for us in this problem statement, is that a legal entity could be a deal in another database. It could be a fund in another database. It could be an investor in one database. It could be considered a legal entity. And so essentially, they're all different things, but they're all the same thing. And so for us, it's important. But then one more thing that I want to highlight here is that on top of that, these organizations typically outsource some of their key deliverables to these big service providers. And so they could be outsourcing their accounting to a fund administrator, where some of this data could be actually generated outside of the firewall. Then it comes in as a whole different thing. So it's not even born there. And then on top of that, I think there's other things where they might actually, outsource their legal documentation to another team. And so when you start doing that, your know-how and your internal knowledge and the context is missing. So you've been hearing a lot about context prompting probably today and all these sessions across all the time zones. One of the things is you're not going to be able to use AI to query this data if you don't know why the data happened, right? Why do we create a blocker entity? Was it because we wanted to create a mechanism where certain investors were not getting tax liabilities? What was the actual plan reason for that? And so now what we're talking about is not just having relationships and all this data in multiple silos, but really, why did something happen, right? And so these are some of the biggest problems that we're trying to solve for our clients as Mike and his team built these solutions we're about to hear in the next few slides.
Yeah, perfect. Thank you, Joskun. Yeah, and so with that kind of problem and with all these disparate data sources, the first thing we do is really build out a tax data warehouse, right? We need to be able to bring all this information at least into one place, and then set up all of the pipelines, set up the data quality reporting, make sure that the information we get is going to be usable for tax purposes downstream. And so our approach here is we use a common data model approach. Right, we define the data model that is needed for tax, and then we align the source data that we get from different clients into that data model, so we have a common understanding of what each data point is. And so that's really valuable, and it helps drive a lot of tax compliance processes. But one of the things that is really important in financial services are the relationships, and these relationships between not only the same entity within different systems, but also also the relationships between entities themselves, right? Within financial services, with investors, they have investors all over the world. They have entities all over the world. They have very complex structures that are designed to get a certain kind of outcome for their investors or their entities. And so it gets really complex, and a lot of different tiers. And so bringing that information into a graph, we're able to really easily now see the full picture of what our client has and kind of the whole structure of their organization. So, here's just a quick little kind of picture of kind of the problem that we just discussed, right? We'll have data in different databases across many different locations. Some of it at the client, some of that at maybe a third party that the client contracts with to do certain aspects of their business. Within EY itself, right? We perform tax compliance work, and so One of the things that we generate are, tax returns. We generate a lot of tax information about our clients' investors and about the client themselves. And so, right in the middle of all this is our data warehouse, which we built in Snowflake. And then, to try to get additional value and additional insights on this information, we move some of this information over into graph database. And so why graph, right? And I kind of talked a little bit about why it's important. Some of these are kind of to make it a little more real, I guess, and highlight some of the really complex questions that matter for a global organization with global investors, right? And all the different regimes of regulation and taxing that they have to deal with, right? And so, one question: how do indirect ownership paths affect our tax consolidation? So basically, there are some rules where if an investor overall has more than 20% ownership of some kind of entity, maybe in some kind of jurisdiction, then they have to do a separate filing, right? And so this ownership is not just direct ownership, so it's indirect ownership as well, meaning that let's say they own 100% of something, and then underneath that that entity they own also owns like 50% of something else. Then like indirectly, right, this investor owns 50% of that third entity. And so it gets pretty complex to try to answer this question across a whole structure of 10,000 entities and 30,000 investors, to really try to understand, hey, do we have any indirect ownership paths that push any of our investors past some certain threshold, right?
Yeah, and I want to be clear here, and I know a lot of computer science engineers on the call. When we talk about entity, we don't mean like a data entity. We're talking actual a legal entity, like a company, an organization, and a partnership, an LLC, an investment. It's a legal concept, right? And so that organization, that company, to Mike's point, he might be an investor. And we say he might actually be a company himself. And then that company might be investing in another company, which then actually has invested in another company. And that company has invested in a deal. But they're all companies. At the end of the day, they're all like these partnerships. And ultimately now what we need to do is we need to figure out, like, these are all, in theory, they're all in the same database. They're in a database called company. But they're all different types of companies, depending on what level you're looking at it. If you were the investor, you're looking at what your deal is, or if you're a deal, looking at what funds you're in. Like, it just changes from what angle are you looking at it, which is why it's so critical to have a graph, because it, like, the different person at the different time of the year cares about different things, and which is why it's beautiful when you're in a graph. You can quickly look at it from a deal perspective. You can look at it from an audit perspective. You can look at it from an accounting perspective. You can look at it from an investment perspective, from a tax planning strategy. You can at any way you want. When you do this in a relational database, it doesn't work. So this is why it's super critical that when we have all these different things that actually are the same thing, but it's just different depending on who is asking the question and what time of the year it is. It makes it very complicated.
Right. Yeah, and so there are definitely many kind of use cases within tax specifically where you need to kind of flow through multiple layers to try to get to the ultimate answer. One of them, a lot of our clients have, as I said, they have many different funds, and some of their investors will invest in multiple funds, right? And so like you'll have one investor who's invested in like 5, 10 different funds if they're doing really well. And so a question that has come up kind of recently is, do any of our investors have, really outsized exposure in any high risk jurisdictions, maybe based on some conflicts around the globe. And so basically, you can first look for, what investments there are across the whole structure that are in a high risk jurisdiction or related to it. Right, and you can kind of trace that up, and these entity structures are very complex, and so it might take 8 to 10 jumps to get to the investors, right? And then so you kind of trace that up, and you say, okay, these are the investors that that are exposed to this high-risk jurisdiction, and maybe you have multiple investments in there flowing up to different funds, and so you want to be able to aggregate that and say, yeah, these groups of investors here, actually, because they're invested in, the 3 of our funds that actually have some exposure, we need to talk to them and see if we can mitigate some of this risk, because like they're going to be impacted if something happens in one of these jurisdictions, right? And so, like as I said, as we go through, there are so many different kind of reasons and use cases where, a lot of this stuff is possible to do within, just like a SQL database. But the problem is you just have to do so many different recursive queries and joins, and you don't really know how many layers it goes, right? I think one of our clients, the longest chain from the very lowest entity to the top is something like 15 or 16 hops, right? And so we don't know how long that a given chain is going to be, and so it's a lot more efficient and a lot easier to have this information in the graph structure for us to be able to really quickly find this information and also show it in a way that's very intuitive for the business team to understand as well. All right, so we'll go into how we built it, and Hans over here is going to talk a little bit about that. Sure.
Yeah, thanks, Mike. So as a developer, I mean, for my personal projects, whenever I start doing some graph stuff, I would just, getting my ChatGPT API case, right? Setting up, initializing my land chain or land graph, right? Started doing some fancy text to cipher, RAG solution or GRAG solution, right? Which stands for graph RAG. And trying to do some fancy graphs and charts. I don't have a goal when I start my personal project. I was just trying to do something very interesting and try to find some insights, right? But in an enterprise environment, is completely different. So we're actually we start from what we call use case. Is more like client expectation, right? That use case is what drives the business value, is what gives the ROI back to the client's investment, because client pays us to do this project. So we actually spent a lot of time doing planning and assessment, right? What Mike said, okay, every client is different, every structure is different, every jurisdiction is different, right? Every investment is different. So we look at all the data from the warehouse we built for the client, and we started just trying to find a very small set of entities or nodes. At that point, it's still an entity, right? In Snowflake, we try to traverse all these tables, trying to find the full landscape associated with that entity. And we need to talk to the client, the stakeholders, the subject matter experts, right? We need to understand what in reality happens, right? Like now there's a conflict in somewhere, and in reality, how your entity is affected. And then we started doing our modeling, right? And POC, we try to see if our query or our solution can actually reach to the same result, right? First try might not be successful, then we go back and try to find another entity and adjust our method, right? So after a few attempts, we kind of, okay, this solution kind of works, and we need to actually load more data, right? To actually validate if our solution, if our algorithm or this use case actually works on a larger scale, right? And then last but not least, we need to automate, right? Because client environment is a highly governed, highly secured environment, right? We have, everybody knows that we have dev, we have QA, we have staging, we have prop. So what we need to do is we need to work with all these stakeholders from the client's different departments, right? We need to prove the data security, the data privacy, and the pipeline can operationalize, right? We stay within your guardrail. There's no security issues with our solution, and then finally we deliver. So that's the approach that we have, right? In terms of delivering a graph solution for a client instead of just building, in my own computer. So if we go to next slide. So I just want to dig a little bit deeper into how we actually start a POC, right? So we kind of, it's a very simplified example. We kind of find a fund, we call it alpha fund, and we start traversing the all the tables inside Snowflake. We found that fund has 2 investments, and that 2 investments actually invested. Is one investment is located in Delaware, the other one is located in Ireland. So we know, okay, this entity is a good example if you want to test some international jurisdiction, tax laws or tax treatments, right? And then we'll pick that entity and we'll start doing our POC.
Yeah, and one of the things to highlight here, right? Since we do kind of come at it from the use case perspective, from like the client value perspective, the business value perspective, a lot of times it's really it's a really cool thing to see when you just put your entire entity structure in a graph and you just see this massive like picture of a web of like your entire structure, and that's like really cool to see, right? But if you want to try to kind of prove out the value on specific things, we really start, the client knows, and we also as well know a little bit about the business of our client, the structures and everything. And so we kind of know what to look for as like a small scale kind of starting out, right? We should bring these kinds of nodes in. We should do the graph algorithms, see if we actually get the results we want. And then from there, we can scale out and bring the rest of the data in, and then be able to trust that like the results that we're getting are going to be what the client's looking for.
Yep. Next slide is go ahead.
Yeah, I just wanted to add one more thing on that visualization. Like all of those nodes, and imagine this big network diagram of 150,000 nodes, by the way. That's what a typical fund organization looks like. But every single one of those nodes are what we call a legal entity. But if you could see in that what they did was they said, okay, well, this is a fund, which technically is a company, and then that fund owns this deal, which is also another company, and then they started adding more things like, oh, they're in this jurisdiction, and oh, here's a tax return. So now they're adding more data, so then you can actually see more things on top of it. Now, so you have this multi-dimensional, beautiful view. So it's Mike's point, it looks very cool, but then you start layering more data on top of it. Now you're seeing a lot of different things. So you can say, show me all funds where I have German investors where we file tax returns in Luxembourg due to the new tax regulation changes. In order for you to do that, split second with a graph database, right? Trying to do that in a SQL query, that's at least 5 joins and inner joins, and basically being able to create like thousands of rows of data and trying to bring it down to the right place. Whereas here, you can, even with text to cipher, as Han mentioned, you can get there just talking to your data. But I'll let Han kind of continue with that.
Yep. So
yeah, so this is an example of just like one fund and some of the complexity, that's in just the very basic information that we apply to it. One of the beauties of the graph is, we can, as we add more attributes to these nodes and we bring in more information, we don't have to redo all the schemas or anything, right? It's just adding more and more value to kind of this foundation that we create. And so just, some of the things that I would say, that we learned as we went through this process for the first time, starting small really helped, right? Basically, our clients would have some question or something they need to investigate that is, not very easy to do within the data warehouse. And so I'm kind of finding these high value use cases, and then being able to show the outcome of that is really helpful. I'm starting simple, right? Not coming in and saying, all right, we have, so much data in our warehouse. Let's just kind of bring everything in and build this massive, complex graph. But really just driving the design of the graph initially with the questions that we're trying to answer and the value that we're trying to provide. Creating the automations in the ETL, even from the very beginning, right? We were working on making sure that we had the pipeline set up so that as we start adding more and more to it, it's really easy for us to bring that information through and see what's in the graph really quickly and try to find the value there. And then finally, seeing is believing, right? We try to explain the concept of the graph and why it's really valuable to business people, and it's just really hard to understand the true value of it unless you start seeing it, unless you start seeing some of those questions that I talked about at the beginning of the session that are really difficult to answer, and seeing how quickly we can get to that answer in this graph ecosystem, and that's really helps drive kind of stakeholder approval of all this. Just a few other things and a few other insights. As we're dealing with business people, tax people, visualizations are really important, right? It's really helpful for them to see. And when we first started doing this, just being able to show a bloom and being able to filter in bloom was like really, really valuable. We've kind of built our own kind of UI with the graph and everything, but just Bloom itself with business users and like they can come in and ask questions and like kind of see the picture changing in front of them and then kind of align that to what they know about their company is really, really, really powerful. Scalability and adoption, kind of talked about this before a little bit as well around the ETL process and just making sure that, everything we do, we try to do it in a way that is very reusable, right? We're in an environment where we have multiple clients, right? We're not just working for one company. And so, kind of the platforms we build out, the processes we build out, we want to do it in a way that's really repeatable and scalable so that we can provide faster value to all of our clients. Key takeaways here. I know we're kind of coming up on time and we kind of actually jump for another session right after this. So I won't stay too long on this, but just kind of flashed up on the screen. We talked a lot about some of this stuff already. So, and this is kind of what we're working on. Obviously we're gonna be working on bringing the machine learning and AI layer into the graph and get some more, some better analytics and better user experience for some of our users who, want to get insights from the graph, but don't necessarily understand how to think about relationships or Cypher or anything like that, right? How do we bring that value to the business? And so we're going to explore a lot about that as well. So yeah, thank you everyone for joining. It was a quick 30 minutes. Yeah.
And hopefully we'll see you in the next session where we're talking about breaking the silos. So we'll see you soon. Thank you, everybody.
Bye, everybody.
Thank you.